Hi everyone. Today in this video, let us discuss about the selective alpha-1 blockers. Let us discuss the chemistry and structural activity relations associated with the selective alpha-1 blockers. What are the alpha-1 blockers? We have few of the drugs which are ending with the suffix zosin. For example, drugs like Progeosine, doxazosin, terazosin and alfuzosin. All these drugs are selectively blocking the alpha-1 receptors. And these alpha-1 receptors are present on the various smooth muscles, particularly they are present on the vascular smooth muscle. So these drugs are acting like smooth muscle relaxants as well as the vasodilators. As these drugs are producing the vasodilatation by directly blocking the alpha-1 receptors on the vascular smooth muscle, these drugs are useful as antihypertensives in the emergency treatment of hypertension. Similarly, another set of drugs are there which are ending with the suffix osin, like the tamsulosin and silodosin. So these two drugs are selectively blocking the alpha-1A receptors present on the bladder and prostate tissue. That's why these drugs are used in the treatment of BPH, benign prostatic hyperplasia. Similarly, alfuzosin is also used in the treatment of benign prostatic hyperplasia. So within the alpha-1 blockers, few of the drugs like the Progeosine, doxazosin, terazosin are more preferred as vasodilators. And other drugs like the alfuzosin, tamsulosin and silodosin are particularly used in the treatment of benign prostatic hyperplasia. Now let us see what are the structural features and SAR related with these alpha-1 blockers. So this is a general structure of the alpha-1 blockers which are ending with the suffix zosin, like the Progeosine, doxazosin, terazosin and alfuzosin. These drugs are having the three important structural features. The first one, they are having the 6+6 membered heterocyclic ring system. This is nothing but the quinozole. We know that quinoline is having the single nitrogen, but when it is having the extra nitrogen at the third position, we call the quinozole. And this quinozole ring is attached by another ring. This is the piperazine moiety. And finally, this piperazine moiety is attached with a acyl moiety. In this way, alpha-1 blockers are having the three structural features. One is the quinozole ring, second one is the piperazine ring, third one is the acyl chain. So here we can start the numbering for the quinozole ring from the nitrogen. So this is 1, 2, 3, 4, 5, 6, 7, 8. In most of these alpha-1 blockers, we can observe the methoxy groups at 6th and 7th position and amine group at the 4th position. Now let us see what is the SAR related with all these three structural features, that is a quinozole moiety, piperazine moiety and acyl moiety. So let us start with the first one, quinozole ring. So within this structure, we can observe the quinozole ring. So most of the alpha-1 blockers are having the quinozole moiety, but in the selective alpha-1A blockers like the tamsulosin and silodosin, we cannot observe this quinozole ring. So quinozole ring is present in the drugs which are ending with the suffix zosin. Now within this quinozole ring, at the 4th position, we can observe one of the group. This is the amine group. So 4-amino group is essential for activity of the alpha-1 blockers. If this group is going to be removed, they cannot block the alpha-1 receptors because this group is responsible for the binding of these drugs with the alpha-1 receptors. Second one is the piperazine chain. So within this structure, we can observe that the piperazine ring is going to connect the quinozole ring to the acyl moiety. So this ring is important, but this ring can be replaced with the other rings. For example, this piperazine ring can be replaced with the piperidine ring system. Otherwise, it can be replaced completely with a alkyl amino chain. So piperazine ring can be replaced with the other structures which are having the nitrogen like the piperidine or alkyl amino chains which are connecting the acyl moiety with the quinozole ring system. Third one is the acyl chain. So now the third part is the acyl chain, which is more important. This acyl chain is responsible for the pharmacokinetic properties of the drug. So this acyl chain influences the duration and bioavailability of the drugs. For example, when we see the duration, we can observe a relation like that D is greater than T is greater than P. That means the doxazosin is having the more duration compared with the terazosin, which is having the more duration than the prazosin. So we can easily remember this sequence as DTP. Doxazosin, terazosin, prazosin. But when we come to the bioavailability, we can observe a somewhat difference in the sequence. We can observe a sequence of TDP. Terazosin is having the more bioavailability, then the doxazosin, then prazosin. So bioavailability is more for terazosin, duration is more for doxazosin. In this way, acyl chain will influence the pharmacokinetic properties like the distribution of the drug in the body, which influence the duration and bioavailability. And these alpha-1 blockers are having the similar structure at the quinozole piperazine moiety, and they are going to differ only by acyl chain. So now let us see what are the structures of the alpha-1 blockers. First one is the prazosin. We can observe that in the prazosin, the acyl chain is formed by furanyl moiety. So a furan ring is attached through a carbonyl group to the piperazine chain. Now what is the name of this prazosin? Now let us give the numbering to this quinozole moiety. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now this quinozole moiety is attached to the piperazine chain by second position. But here what is the principal functional group? The principal functional group is the ketone. So we have to give the preference to the ketone such that the suffix of the name becomes methanol. Now this methanol is attached with the two chains. One is the furan attached by second position, so furan 2-yle, and another one is the piperazine chain attached by first position. But this piperazine chain is having the another side chain at the fourth position, so we can write this as 4-piperazine 1-yle. Now at the fourth position of this piperazine, the quinozole moiety is attached. So this quinozole moiety is having the amino group at the fourth position, so 4-amino. It is having the methoxy groups at the 6th and 7th position, so 6,7-dimethoxy. So we can fill in this gap, 4-amino, 6,7-dimethoxy, quinozole 2-yle. That completes the name of the prazosin. So prazosin is having a furanyl moiety as the acyl chain. Second one is the terazosin. Terazosin is a similar structure where the furan is going to be saturated such that it is going to be converted to tetrahydrofuran moiety. Now again we can give the numbering to the quinozole moiety like this, and here again the ketone forms the principal functional group, so the suffix is the methanol. This methanol is attached with the tetrahydrofuran ring, but we can consider this as oxygen containing saturated system, so that is oxalon 2-yle. So now we can consider this as oxalon 2-yle. Then remaining is same, 4-piperazine 1-yle, 4-amino, 6,7-dimethoxy quinozole 2-yle. That is nothing but the terazosin. So prazosin is having the furan, whereas terazosin is having the tetrahydrofuran. Third one is the doxazosin. Doxazosin is having somewhat large structure as an acyl moiety. Now again here the principal functional group is the ketone, so this is the methanol. But this methanol is attached with the one of the chain. What is the name of this chain? So this ring is having the benzene attached with a 6-membered ring system with 2 oxygens. So we can write this as 1,4-benzodioxane 2-yle. But it is somewhat saturated at the second and third position. So we can write 2,3-dihydro 1,4-benzodioxane 2-yle. That is the ring system present as an acyl moiety. And then the remaining is same. It is 4-piperazine 1-yle and 4-amino, 6,7-dimethoxy quinozole 2-yle. That is the doxazosin. So doxazosin is having one of the ring system, that is nothing but the 2,3-dihydro 1,4-benzodioxane 2-yle, which is attached to the ketone. And doxazosin is having the long duration of action because of this acyl moiety. Next one is the alfuzosin. You can observe that alfuzosin is not having any piperazine ring system, but it is having an open chain that is connecting the quinozole moiety with the acyl moiety. Now this is the numbering for the quinozole ring system. And what is the principal functional group here? Here the principal functional group is the carboxamide. This carboxamide is attached to the tetrahydrofuran just like in the terazosin. This tetrahydrofuran can be considered as an oxalane. So now this is nothing but the oxalane 2-carboxamide. That is a suffix of the name. And then on the nitrogen we can observe the propyl chain, 3-carbon chain, so N-propyl. And this propyl side chain is attached with a methyl amino at the third position, so 3-methyl amino. And this methyl amino group is attached with the quinozole moiety. Now the rest of the name is similar to the other drugs. So this is 4-amino, 6,7-dimethoxy quinozole 2-yle. That is the alfuzosin. So you can observe that in the prazosin, doxazosin, terazosin and alfuzosin and all of these drugs, the amino group at the fourth position is always present, which is essential for the activity. And piperazine chain is required, but which can be replaced with the other chains. Just like in the alfuzosin, we can observe a alkyl amino chain. And the acyl moiety mainly influence the duration and bioavailability of these drugs. Next one is the selective alpha-1A blockers. We have two drugs like the tamsulosin. You can observe tamsulosin is not having any quinozole moiety. This is one of the selective alpha-1A blocker which is used in the treatment of benign prostatic hyperplasia. And similarly another drug is the silodosin. This is again selective for the alpha-1A receptors and used in the treatment of BPH. In this way, most of the alpha-1 blockers are having the three important structural moieties: quinozole moiety, piperazine moiety, and ethyl moiety. These structural features are not observed in selective alpha-1A blockers like the tamsulosin and silodosin, which are used in the treatment of BPH. So that's about the alpha-1 blockers. Hope you have enjoyed this video. If you like this video, please subscribe to our channel, share this video with your friends, post your comments in the comment box. Thank you for watching this video.